All right, our viewers want to now move into linear momentum in physics. So let's go over the laws. First law of motion says that every body will continue in a state of rest, or it is going to move in a straight line. It's going to continue to move, or it's going to remain where it is, except an external force acts upon it. So that is Newton's first law of motion. Number two, that's also called the law of inertia. Number two is the Newton's second law, which says that the rate of change of momentum is proportional to the applied force. So that will bring us to the first line of formula that we're going to have. The rate of change of momentum is proportional to the applied force. So that the force applied determines the rate of change of momentum. So with that I have F equal to M bracket V minus U. Then Newton's third law says that every action there's an equal and opposite reaction. Yes, every action is an equal and opposite reaction. So from this now we can push further to state our several founding principles or formulas that will help us to deal with problems relating to linear momentum. By cross multiplying, I'm going to have Ft to be equals to M bracket V minus U. So I want you to take notes. Right here, Ft here simply means what? Impulse. Impulse is F force times time. Then this is what? Change in momentum. If I'm asked to find change in momentum, my formula actually is M bracket V minus U. If I ask to find impulse, it's force multiplied by time. But in the case where I have any of these parameters, I'll solve using that first formula. So as we progress, you will see the right formula to use in different case. Take note, they are units of either impulse or momentum. Yes. As we progress on this, you need to also go back to recall your fundamental and derived quantities in physics, because the formulas are right there. Once you know those things, it helps you to follow up with what we are dealing with. Yeah. So the unit of impulse and momentum is what? Newton seconds or kilogram meter per seconds. How do we get our unit in physics? Force is measured in Newton, time is measured in seconds. So if it's force multiplied by time is Newton seconds. So yeah, mass times velocity is the formula for momentum. Mass is in kilogram, velocity is in meter per second. So whenever you see this unit, know that it is for um, the impulse and momentum. You must also know that impulse is defined as the product of the force and the time during which it acts on a body. So product of force and the time which it acts on a body. Let's take example one. This is a very simple subject. You just need to understand the basics. The first question says a net force of magnitude 0.6 Newton acts on a body of mass 40 grams initially at rest. Calculate the magnitude of the resulting acceleration. So the first parameter we're given there is what? Force. What is the force? 0.6 Newton. Even if I don't know so much in physics, whenever I see unit as Newton, I know it is unit of force. That's why I must know my derived and fundamental quantities. So also give us the mass there. Mass is 0. Sorry 40 gram. Like we had said, go back and understand your fundamental quantities. If you notice in your fundamental quantities, the unit of mass is kilogram, not gram. So we must convert, like I said, we must convert to what? Kilogram. How? Divided by 1000, you have 0.04 kilogram. So having gotten that, what's your formula? Force, you're looking for acceleration. Acceleration is unknown. Now force is equals to mass times what? acceleration. Mass times acceleration. So in linear momentum, we it is Newton's second law that gives us this what's called mass and acceleration, because acceleration is change in momentum over time, change in velocity over time. So that's acceleration. V minus u. Acceleration in itself is v minus u over t, change in velocity over time. So force is mass times acceleration. My force here is 0.6, my mass is 0.04, right? Yes, times acceleration a. And divide by the coefficient 0.6 divided by 0.04 give me 15 meter per second square. So that is it for that. Next we go into is a truck of mass 3,200 kg moving with a velocity of 10 meter per second. So the truck is moving with a velocity of 10 meter per second. Increases its velocity to 20 meter per second in 5 seconds. Calculate the magnitude of the force exerted on the engine. What is the first parameter given there? Mass is 3,200 kg moving with a velocity of 10 meter per second. So that's the initial velocity. Yes, those parameters as given, u represents initial velocity or speed, and v represents final velocity or speed. Your F is your force, your M is your mass. So I believe this would help us. Then we know that F is equals to ma. Also F is equals to change in momentum over time. Okay, so that's for that. Then we go on. It says the mass is 3,200 kg, has a velocity of 10 meter per second. So it's going to increase its velocity to 20 meter per second, which means the final velocity is 20 meter per second. In 5 seconds, your time is what? 5 seconds. Calculate the magnitude of the force exerted on the engine. You're looking for force. So look closely. Which of these formulas are we going to use? Is the first or the second? Obviously, is the second because of the parameters we are given. We're going to use the second. Good. So we have F is equals to M bracket V minus U over T. M is 3,200. Final velocity 20 minus initial velocity 10 over time 5 seconds. 3,200, 20 minus 10 is 10 over 5. And once 5 divided 10 is 2. So 3,200 times 2 gives me 6,400 Newton. I told you physics is very, very simple. You just need to follow along and then you will understand what we're calculating. Next here is a body of mass 20 kg is set in motion. So already they've given us the mass. Mass is what? 20 kg. And they said it is set in motion by two forces, 3 Newton and 4 Newton, acting at right angles to each other. So those two forces, 3 and 4, they are at right angles to each other. Of course, there will be a resultant. The resultant will be gotten using Pythagoras theorem. That should be 5 Newton. Remember your Pythagorean triples. If the two sides of a right angle triangle is 3 and 4, your hypotenuse must be 5. If it is 6 and 8, your hypotenuse must be 10. These are Pythagorean triples. How do I check? 3 raised to power 2 is 9, 4 raised to power 2 is 16, 9 plus 16 is 25, which is the square of what? 5. Then also 6 raised to power 2 is 6 raised to power 2 is 6, 8 raised to power 2 is 64. Then when you add them, you get 100, which is 10 square. You must know your mathematics to be able to deal with some of these problems. Okay, so since the both are acting at right angle to each other, the resultant force is 5 Newton. You're not going to use 3 or 4, no. Take the resultant. Now you are asked to find the acceleration. Acceleration you are asked to find. Mass is already in kg, so no conversion. Force is equals to ma. That's the first formula you're going to use. Your force is 5. The mass is 20 times your a. Of course, divide by the coefficient. And that will give you what? 0.25 meter per second square as your acceleration. I hope you are following, and I hope you understand what we are doing. Please do well to like, follow, and then share to your friends. Let them encourage. Share to your friends, share to others, and that is it. Let's take the next question, which says a moving car of mass 800 kg experiences a frictional force of 2,200 Newton if it accelerates at 2 meters per second square. Calculate the magnitude of the force applied to the car. What's the first thing given to us here? The mass of the car. The mass is 800 kg. It experiences a frictional force. Friction 200 Newton. Of course, in any movement, if I must be able to successfully move, I have to overcome friction. Imagine if friction is 200 and I only produce 200. It means I will not move because I'm just, what I have is enough to only cancel friction. So for me to move, it must be my extra over the friction. That will determine the force I will use to move. Then it says if it accelerates at 2 meters per second square, acceleration is 2 meters per second square. Calculate the magnitude of the force applied to the car. So we're looking for the force applied. Force applied. What will be the force applied? Now, please pay attention. If friction is 200 and it is moving with 500, what force do I need to apply? I need to apply 700 so that it can move with 500. Because the truth is that if I apply 700, 200 is the friction. It has to, you minus the friction, then you have 500. That is the net force of its movement. So I can tell you that the force applied is the net force. The force is able to use to move plus friction force. Not actually what you must apply. If I apply 1000, of course it's not going to use 1000 to move. It will use 800 to move, and then friction is what? 200. So that 1200 was used to overcome friction, then 800 is what is using to move. So if I'm looking for the force applied, I already have friction 200. My job is to find the net force, and I can now find what is applied to get that force of movement. So from there, what is my net force. My net force based on this parameter given is what? This force is what? Mass times acceleration, which is 800 times 2. That's 1600 plus my 200 that is friction give me 1800 as my applied force. So he applied 1800 and was able to move with 1600 because 200 was cancelled out due to friction. So that is how we deal with linear momentum problems. I believe these questions will really help you a long way.